Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about the relative solubility in water of various substances, and we're going to look at predicting what the relative solubility is in water. So let's get into this. So one of the things you got to keep in mind is the like dissolves like rule, and again what that's referring to is the similarity in the what we call the intermolecular forces, IMFs. So if you have similar intermolecular forces, you're going to probably mix well. If you don't have similar intermolecular forces, you're not going to mix well. So here, to put it simply, is that polar substances are going to dissolve other polar substances, and they're going to mix well. And non-polar substances are going to mix well with other non-polar substances. So polar dissolves polar, or is soluble in polar, or nonpolar is going to be soluble in nonpolar or mixes well with nonpolar. So what do you do when you have both polar and nonpolar groups in your molecules? Well, here you got to look at like how big is this nonpolar group? How many polar groups do you have in the molecule, and see what the balance is. Typically, if you have a chain of carbons, in order for it to be soluble, you probably want one, say, oxygen or hydroxyl group per 2 or 3 carbons. That's usually going to allow it to be more soluble than not. Okay, so let's look at these two examples. So here for A, we're given stearic acid and we're given butanoic acid. Now here, again, it ends in acid, and the IC, the ic acid, should tip you off that this is our carboxylic acid. And again, the carboxylic acid group is this group right here, the C double bond OOH, right? And here we have it here as well. So that ic acid tells you that it's a carboxylic acid group. And so we have two carboxylic acids here. So the stearic acid has the carboxylic acid group, and that's a pretty polar group. But then you see this really long chain of carbons and hydrogens. So you've got this very non-polar group, which we could say is hydrophobic, right? It doesn't like water. Water doesn't really like it. So here we have what is called the hydrophilic group. So again, hydrophilic is water loving. This likes water. This doesn't like water. And so if we compare this to this molecule, here we have a much smaller hydrophobic chain here, or carbon chain. So this is going to be a non-polar chain. But here we have, again, their carboxylic acid group, which has got 2 oxygens, very polar, and you've got 3 carbons. So if we're to figure out which one would have the larger relative solubility in water, it would definitely be the butanoic acid, because it's got a much smaller hydrophobic group or non-polar group compared to the hydrophilic or polar group. So this would be definitely more soluble in water than this one. This here, this long hydrophobic group, would pretty much make it very insoluble in water. It would probably be slightly soluble, but not very much. Okay, what about B? Here we got 2-methyl-2-propanol, and we have methanol. Okay, so methanol, you can tell by the OL, right? The OL ending should tip you off that these are alcohols, and that an alcohol has an OH group on it. And here we have the OH group here. Here we have an OH group here. Again, these are not hydroxy ions. They're not negative ions. This is not OH minus and OH minus. These are called hydroxyl groups. Okay, so we're dealing with alcohols. We got oxygen here, and we got 4 carbons. So we got this polar group, and we got this non-polar group here. And then here we have OH, which is polar. But then we got like 10 or 11 carbons here. Remember, in the line structure here, we at every corner there is a carbon. So Here we have a carbon, carbon. So it's assumed that at every bend or corner, there's a carbon. And at any end, there's a carbon too. So we have 1, 2, 3, 4, 5, 6 carbons plus 7 here, plus 8, 9, and 10. So we got 10 carbons here with one OH group. Here we have 4 carbons with one OH group. So this is going to be the much more hydrophobic or non-polar group. That's going to keep it from being soluble in water, or as soluble in water as this one. So we would predict that this one here would be more soluble in water than this one, based on how smaller, relatively small, the non-polar group is compared to this one here. So methanol would not be very soluble in water. And so that, ladies and gentlemen, is how you determine the relative solubility in water of different substances. I hope this was helpful. If this was helpful, give me a moment. Sorry about that. Again, as I was saying, if this was helpful, then please, by all means, like the video, share the video with your friends, hit that like button. Also, don't forget to subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you want me to go over for you to help you out, or a topic you want me to cover, please let me know. I would be happy to do that for you. Thanks for joining me, and have a great day.